Okay, so very good, everybody. Well, thank you. So let me start. My name is Justin Kutu. I'm the president of R&D Technologies. I wanted to kind of welcome everybody to our virtual open house. My apologies that we have to do it virtually and you can't come and join us and have some breakfast with us and come see the machines up front and see what the capabilities are and even bring some parts and see how get your hands dirty and see how everything operates. But hopefully at some point we'll be able to do these again and you'll be able to come into the shop and get the full tour. But this is what we have to offer for now, and hopefully we get some good information over to you. And again, we have some good sound speakers with a lot of expertise in the field going to be talking to you about the different technologies. So real quick, I just wanted to quickly introduce Colin Mulvey. He's one of our applications engineers here. Colin will be handling questions in our in the Q&A. So if there's anything that we're talking about during our presentation, please just submit a question to Colin. Hopefully he can answer it quickly for you. And otherwise, we're going to regroup at the very end, open up a full Q&A session and help everybody out with whatever questions, specific needs and applications that they want to go over. So we'll start with that. So again, I wanted to kind of give everybody a quick overview, a little bit of who R&D Technologies is as a company. So, I want to kind of explain to everybody, where we started, kind of where we are now and what we're looking to achieve. So R&D Technologies, we were established in 1998 as a SolidWorks reseller in New England. Coming on the ground floor, basically selling and training and servicing SolidWorks, which is basically a very powerful 3D CAD software, which I'm sure a lot of you already know that. So coming in, this was 3D software at the time. SolidWorks was a game changer in all design and manufacturing processes. It was great to get in on the ground floor, get to be with a lot of manufacturing companies, design and manufacturing companies, and see how it improved and progressed their processes as things went along. So we were what you call a VAR or value-added reseller partner of Stratasys for SolidWorks for quite some time. At that time, we were starting to venture in the world of 3D printing and wanted to kind of partner with a 3D printing company to sort of match the capabilities that we already had and sort of our install base of people that were already currently using 3D CAD software. So we finally matched up with a company called Object Geometries somewhere around 2006, 2007. Again, partnered up with them. We were a value-added reseller for them. We were selling their technology, which is called Polyjet or Polyjet Matrix technology, which is, again, we're going to discuss this later into our presentation, but it's basically using liquid photopolymers, jetting them through print heads and curing with UV light and breakaway. It's like a wax material, using a wax material or now a soluble material. Again, we're going to jump into that a little bit into our presentation, but that's sort of a little bit about what Polyjet was when we joined with Object, and that's sort of where we were with them. A few years later, Object Geometries and Stratasys, now I'm going to get it right, joined companies together, which was a beautiful thing for us. Two completely different technologies were able to join and come under one umbrella. And it was great. It was a great opportunity for R&D Technologies, great opportunity for both those large 3D printing companies. And what Stratasys offers is something called fused deposition modeling. And again, I apologize if a lot of people already are very familiar with all this, but we will discuss a little bit more in depth what fused deposition modeling is, FDM, into the presentation. But what it is basically extruding thermoplastics in pressurized heated chamber machines and giving and creating parts that are production quality plastics. So again, we will go over that a little bit more in depth. With the merger of these two companies, R&D Technologies decided to ramp up its already established 3D printing business. So we were an additive manufacturing service bureau prior to kind of joining up when Stratasys and R&D Technologies, when Stratasys and Object joined. And we were basically asked by Stratasys if we were able to, be part of something called a global manufacturing network, one of only 7 in North America. So what this was is basically giving us outreach to many other companies, but 6 other companies that were a lot like ours. So that were building parts for basically, service bureau and, being able to outreach to different companies that needed this kind of service that didn't have the capabilities already in-house. So that was an excellent opportunity, but it also gave us a much larger position in the market, because with that, we're not just working with additive manufacturing, we're working with every level of manufacturing. So we're doing things from, CNC, but well, let me start with additive manufacturing, but we're doing it with SLA, we're doing it with, SLS, we're doing it with every kind of additive manufacturing service. And also we're doing it with, CNC, injection molding, and everything from and that and post-processing. So it became something that we really were part of a bigger opportunity. And that was something that we were excited to launch and become part of, and hopefully give those capabilities to our customers. So now R&D Technology strives to offer as many things in design and manufacturing spaces as possible. So we offer 3D CAD consulting work, material sales, machine services, and so on. We're making constant moves to research all new technologies which can take our customers to the next level, from concept to beta faster and more efficiently, time to market, beating out your competition, stronger, long-lasting quality parts built with less waste, time, and material costs. So, that gives you a little bit of an understanding where we are right now. Again, we are well aware of the difficulties that Corona and COVID-19 has put upon all of us, and we share those hardships with you and the pitfalls. And we're here to support you in any way we can. We're trying to stay positive. We're staying focused on supporting our customers and new customers, people that have, the desire, the alacrity to reach out and still start, start building again and putting out projects. So I look forward to hearing from everybody later in the call. If anyone has any specific needs or applications they would like to go over during our Q&A, I greatly appreciate your questions. I encourage them. Hopefully we can strike up some conversations, help you with any projects that you're currently working on or that you may have in the future. So thank you again for letting me to talk to everybody. It's a pleasure to have everybody with us today. And I look forward to hopefully chatting with you all later on the call. And everyone, you'll have all of our contact information later on. So if you want to talk offline, that'd be great as well. So with that, I'd like to introduce you to our technical sales rep, Charles Havens, who is going to discuss with you a little bit about FDM technology. Take it away, Charles. Thank you.
Appreciate it. Thanks, Justin. So yes, I'm Charles, and I'm one of the R&D Technologies outside technical representatives working with businesses in the Connecticut and the Rhode Island areas. So I'm going to take a couple of minutes to talk about what I see in the field with businesses that are using the Stratasys FDM technologies. Now, as a field rep, we get to walk with you around the shop floor and get a deeper understanding of what your current processes are and what you're looking to gain with using 3D printing. So some of the areas that we can talk about with FDM technology, it can be jigs, it can be fixtures, tooling, it can be utilized with thermoforming, prototyping, and why not use it for end-use parts for functionality and weight savings. So what FDM is, as Justin had talked about, is basically extruding a hot polymer, creating the design that is already your CAD model. So what starts out as a simple idea, or it can be turned into a simple fixture, can now allow you to envision an entire new way of thinking, including utilizing with lean manufacturing. So weight savings alone with some of these parts, if you take a traditional steel or milled part, and if it can be redesigned with the comparable structural functionality, weight savings alone using a nylon 12 carbon fiber piece can be considerable. And 3D printing can work alongside all of your traditional methods of tooling while creating a digital inventory with your part being on demand. So one industry that has embraced the FDM technology is the aerospace industry. From the certified aerospace Ultem family of materials up through the ABS ESD7, which is an electric static dissipating ABS plastic, there are parts that are in use today on commercial aircraft, rockets, satellites that are basically in orbit today. So closer to home, again, we can walk with you around your shop floor to uncover these areas where 3D printing can be applied. One other area that I kind of get passionate about is safety. So 3D printing with color coding guards in specific colors that are eye-catching to the eye may actually help you in keeping any injuries from occurring. And if you are ISO or ITAR certified, color coding tools or your tool crib can actually help with keeping your ISO and ITAR jobs specific tooling utilized so that there's no cross-contamination, wrong tools for the wrong job. So these are a few of the many applications that we see, and feel free to reach out to us. Again, this is interactive. We want your questions. We want to get some feedback from you, especially on your future projects and where we can help. So this is a little bit about FDM. I'm going to turn it over to Alex Brown now. He's going to talk a little bit more about the Polyjet technologies.
Thanks, Charlie. As the other technical sales representative with R&D Technologies and working in Northern New England, I come across many customers that have unique prototyping needs that require finer details and color iteration that our FDM technology, which Charlie explained, sometimes cannot provide. So similar to the animated video I put up for FDM, I have just a quick animated video for our Polyjet just to kind of demonstrate it. So to get into Polyjet, Polyjet is basically our other main technology that we provide customers alongside of FDM because it's the perfect complement because it utilizes UV curable resins that can be built in accurate, rigid, or flexible parts to meet our customers' needs for building prototypes. We have also worked with customers in industries such as architecture who utilize our Polyjet printing technology to fabricate their building designs and to scale down 3D printed models in order to show clients, to show construction teams, and even in some cases show city planning committees as a proof of concept before they're approved breaking ground of a new building. These architecture firms do utilize our Object 30 desktops for basic conceptual design, which can print their models in a single material, just kind of get the shape and the relative architecture of the building. Further down the line for these architecture firms, the design validation stages require a lot more requirements, and these firms start getting into using what's known as our Connex or our J-series Polyjet technology that can print detailed models that have full color and texture characteristics if desired or needed. Similarly to architecture companies, other product development teams, whether it's toy companies or shoe companies, use that same Object 30 desktops to produce their models in just a single Vero material, which Matt Maloney, our engineer, will get into a little bit later. And when these product development teams get closer to finalizing their full color prototypes and the needs for that, their engineers and designers for these product development teams can work together in using full color and flexible Polyjet technology to produce an optimal design before they go to production of the particular product. Whether it's full color models or functional mechanical models, these prototypes can be built on the same system, and even in some cases, these prototypes can be built on the same build tray within the Connex or the J8 series platform. We've also seen the Polyjet technology being used for, in some cases, light tooling. This is mostly in regards to medical device manufacturers that often have needs for smaller custom one-off fixtures that don't necessarily need too high strength, just something that's pretty accurate. They can save up to $1,000 per month, get their tools in their hands days and weeks faster by utilizing the single print capability of the Object 30s instead of relying on traditional methods such as CNC machining, which Charlie and I see on the field. Most cases have a huge backlog. You see a lot of these tools take months to get built. We also see the Object 30s are great for making fit and form prototypes. This is mostly in terms of designing complicated instruments, such as mass spectrometers, DNA sequencing machine, and it gives the designer and engineers the ability to make accurate fit and form prototypes to further validate the design of these complicated instruments. Our customers what we find, Charlie and myself, have the option to either invest in this technology for an in-house solution, but you know, a lot of our great customers, some of them prefer to use our services for quick turnaround parts that they don't need to spend labor internally to create. And that's where our service bureau and our additive manufacturing shop really comes into play. So to get into more details on our services, we go over to Jordan Novak, our vice president, to get an up-close tour of our additive manufacturing shop.
Thanks, Alex. Thanks, Charlie. Good morning and welcome to our Additive Manufacturing Center. My name is Jordan Novak. I'm the Vice President of R&D Technologies. And today I'd like to give you a high-level overview of our service bureau, our capabilities, and what it is that we do here. We create parts for many industries in our current customer base, from jewelry to aerospace. We have a rapid prototyping center, and our inventory here allows us the capabilities to produce parts in an on-demand setting, and in many cases deliver parts directly to you the very next day. So what does our service bureau do? First and foremost, we're a parts provider. Whether you're a small design firm that needs multiple reiterations of designs, or you're a large-scale manufacturer and you need to have on-demand parts produced in large scale, we have the capabilities to meet your needs. We have 50 machines here at our disposal to take an order quickly and put it into production. And our customers enjoy a very fast turnaround without waiting in line for weeks like some of the parts providers. Some of you may also have machines like this already in-house. We provide overflow parts capabilities for our customers. So as many of us come out of this COVID situation and manufacturing and prototyping returns back to normal, you may experience a backlog and you're trying to keep those production schedules on task. You can utilize our service bureau to keep your production schedule on task and keep those keep your design process flowing. Also, we can provide you CAD services if you don't have an in-house CAD designer, or again, if you need any type of overflow, we have highly skilled engineers here at R&D that can meet the CAD needs. Now, we have a couple of different manufacturing capabilities that Charles and Alex alluded to. And the first one that Charles went over was FDM. R&D offers FDM for our customers, and our FDM machines produce, utilize thermoplastics and layer heights as fine as 5 thousandths of an inch, and they go up to 20 thousandths of an inch. Our FDM machines, they utilize production-grade thermoplastics that are environmentally and mechanically stable, and our machines can complete parts with complex geometries and cavities that would otherwise be problematic through other methods of production. The second method of production that we had here that Alex alluded to is Polyjet. Polyjet utilizes the photopolymers, jetting as fine as 14 microns to produce smooth, accurate prototypes and parts. Our Polyjet technology has the accuracy and definition to produce prototypes that convey final product aesthetics, but can also produce strong parts like for jigs and fixtures. Beyond the accuracy of the parts, the Polyjet machines can replicate colors up to 500,000 different tones, and can take specific Pantone or RGB codes to replicate your specific color needs. Lastly, we also provide solid-scape printing. Solid-scape printing is an ultra-high resolution wax model. This technology can be utilized to produce high-resolution models for investment casting that are primarily used for the medical and jewelry industries, but can be utilized across multiple industries. Now, quickly, I'm going to flip my camera around and kind of give you a walk around the room and go over a few of the machines that we have. I'm going to take you over here to the FDM side of the house. Here we have our two Fortis 450s. These machines have a 16 by 14 by 16 build chamber. Both the machines have high capacity material options to increase unattended builds for up to a 2-week time period. The 450 on the left here is printing an ABS ESD7 currently, and the 450 on the right is currently printing in nylon 12 carbon fiber. These machines can print in a full line of Stratasys thermoplastics from ASA to Ultim. And like I said, they do have, they can hold multiple canisters of material, so you can go for long periods of time for unattended long builds. They're excellent machines, can produce pretty much anything that your designers can come up with, and are very versatile. Moving along in our shop, we also have two Fortis 250s. These machines have a 10 by 10 by 12 build chamber and print in the ABS plus material. These are great versatile machines for entry level. They can produce fine, accurate products and prototypes for whatever your needs are. Moving along, we have our Stratasys F350, excuse me, F370. F370 has a 14 by 10 by 14 build chamber. This is a great office printer that requires very minimal setup. This machine has fast and easy material changes utilizing the same extrusion head, and it's one of the only machines that can produce parts in TPU and DIRAM. Here we have our solid-scape machines. Our solid-scape machines, like I said, produce ultra-fine wax models. They have a 6 by 6 by 4 build chamber. And sliding over, we have our largest machine in our inventory, which is the Fortis 900. The Fortis 900 has a 36 by 24 by 36 build chamber. It can produce large-scale printing in one build. Just like this child seat here, very large build that you can print in this machine in one print without having to do any kind of splicing of your design. Also, another added benefit of the Fortis 900 is you can do large-scale production runs. This machine was fantastic during the height of COVID. When we were running this machine, we produced 36 individual masks at one time. So we were able to do large-scale production runs utilizing this machine. So if you're looking to produce multiple parts at one time without having to have someone man a machine or constantly switch it out, the Fortis 900 could definitely be a great option for you. Moving along in our shop, we also have a Fortis 380. This Fortis 380 also has all the options of a Fortis 450 still. The only differences are it just has a 14 by 12 by 12 build chamber and has a single canister load bay rather than a dual canister load bay. In our shop, we also have a Fortis 400, which has a 16 by 14 by 16 build chamber. And now we're going to slide over here to our Polyjet side of the house. Here we have our two objects. We have an Object 30 here. These objects print in single materials. They have a 11 by 7.5 by 6 build chamber. These machines produce ultra-fine models down to 28 microns. They build in a single material at a time and can print up to 8 different materials, including rigid opaques in the bureau line. Here we have our Connex 500. Our Connex 500 can print 2 materials at a time, including digital rubber-like materials. Has a 19 by 15 by 8 build chamber and builds as fine as 16 microns. And as just like the video that Alex showed you earlier, we're currently running a job on this machine. And then finally, we're going to slide over here to the latest and greatest model that we have here, which is the Stratasys J850. We recently upgraded into the J850. We're extremely lucky to have one of these here in our shop. One of the only service bureaus on the East Coast to have one of these. The J850 has a 19 by 15 by 8 build chamber. Builds as fine as 14 microns. Like I said earlier, has the capability of producing to over 500,000 different tones of color, including your specific Pantone or RGBs. This machine also prints the full line of Vero materials, as well as the Agilus 30 family, if you're looking for any type of flexible materials. It can produce rubber-like materials with Agilus from Shores 30 to 95, and also has the ability to print digital ABS materials, digital ABS 2 in both ivory and green. So that's a quick tour around the print room. I'm going to send it over to Matt Maloney, who is our applications engineer manager. But like we said, we want to hear from you. And if you want to see our shop live and in person, we can host you in very, very small groups if you want to see these machines. So with that, we hope to see you. Matt, take it away.
All right, thank you very much, Jordan. So I'm Matt Maloney. I'm the applications engineering manager here. I've been here with R&D for about 7 years or so. I'm going to take you through the materials really quickly. I'm going to try to give a very high overview of them so we don't get into the fine details, but certainly open it up to questions towards the end here if you want to learn a little bit more about the materials yourself. So starting off with Polyjet, and the Polyjet is all acrylic-based materials. They do have full color rigid materials that can mimic both polypropylene and ABS as well. This is where we can get into Pantone verifications, the over 500,000 different colors, and they're all in one print. They are a little bit brittle because it is acrylic material, and they don't hold up to very, very high temperatures. Usually it's around about 130 degrees Fahrenheit or so. So it is kind of marketed more towards a trade show model or a kind of a show and tell model as opposed to an end use product. And then as well, the other thing that you can do is you can do rubbers. So we can do anything from down to a Shore 27A rubber all the way up to a Shore 95A rubber. So if you're trying to simulate, you know, grips on a razor or buttons on a pad or something like that, we can certainly simulate it for you and get you kind of that realistic part that you're looking for. Moving on to FDM, we've got higher grade thermoplastics, so they're going to hold up to a little bit higher temperatures. Starting off in the range, we've got ABS and ASA. These are good general purpose materials. They have a little bit of flex to them. ASA is basically just a UV stable ABS. There is a M30I, which is a sterilizable version for medical use, where they're trying to sterilize things for either contact or what have you. There's also an ESD version of it. So there's ABS ESD7, which is good for electrostatic dissipative applications where you're trying to shield electronics from static discharge, or maybe on a high production flow assembly line where you're building up that static with a bunch of parts running across the bars and stuff. From there, we've got PCABS, which is a mix of polycarbonate and ABS. This is good for high impact applications. You have polycarbonate, which is good for high compression strength, not so much for tensile strength because it is sort of glass-like. And then there's also a sterilizable variant of polycarbonate as well, again, for medical use. There's one of the versions is a translucent, which is one of the few translucent materials that we do have on the FDM side of things. And then moving on from there, we've got a bunch of different nylons. So you've got nylon 12, which is good for flex, it's good for impact, and it's also good for chemical resistance. There is a nylon 6 variant, which is a stiffer version of the nylon 12, and that one runs on the 900 only. And then lastly, we have the nylon 12 CF, which is a carbon fiber variant, and it's got chopped carbon fiber in it for added strength and stiffness. This material is good for replacing some of the steel jigs and fixtures that you have. Very, very high strength, but it is a little bit rough as far as the surface finish goes, just because of the fibers that are sticking out of it. And it can't have any trapped supports because it is breakaway only support. The other thing is that because it is the chopped fiber, it tends to be a little bit more isotropic than perhaps a laid carbon fiber strand. So it has better strength overall as opposed to in just maybe one or two directions. Moving on from there, we've got Dyran 410 MFO3, which is a 3% mineral filled nylon. This is very similar to Delrin. It's very lubricious, so it's got a nice glide if you're looking for parts that are going to have a lot of friction on them or anything like that. It's a good all-around tooling material. Also, you've got TPU, which is a Shore 92A flexible rubber that can run on the 370. The one thing to keep in mind about the TPU is that because it's the FDM process, it's not going to be watertight or airtight, but it's good for vibration, for feet on different applications, or if you're trying to do some sort of flexible mock-up. Again, if you want to do some sort of airtight setting, you might have to put some sort of sealant on it. Going on from there, the higher temp materials, we've got Ulton 9085, which is a high temp material. There's no outgassing. It's good for aerospace applications. Right now, Boeing uses it a lot in a lot of the non-flight critical parts on their planes for ducts and that kind of thing. And then there's an Ulton 1010 material, which is kind of like the PC in the fact that it's somewhat glass-like, but it's the strongest material compression-wise, not as much tension-wise. It is the highest temp material. It holds up to about 421 degrees Fahrenheit, and it is autoclavable. So again, if you're looking on the medical side of things for sterilization, being able to autoclave it is, that's the highest temp material that we have that can hold up to those sorts of temperatures. Also on the high temp side, we have Antero 800 NA, which is a high temp material with chemical and fuel resistance. So it's good for anything in contact with oil and gases, mostly in the oil industry. We also have Antero, a newer material called Antero 840 CNO3, which is 3% by volume carbon nanotubes. So very high strength, high heat, and again, good for aerospace applications or very high-end electrostatic dissipative ones. And then that's pretty much it for the FDM side. As far as the SolidScape goes, it's just a high resolution wax, and it is meant for full burnout. So it's good for precious metals. It's not going to leave any ash in the casting. So you get a nice clean pull out part. And I think that's about it. So that's kind of, like I said, a very general, brief overview of the materials to kind of give you an idea. Again, if you have any more questions, you want to know a little bit more, certainly feel free to reach out to us in the Q&A towards the end here. So right now I'm going to pass it over to Chris. He's the customer support manager, and he's going to walk you through the customer support side of things.
Thanks, Matt. So again, my name is Chris. I've been with R&D Technology since about this time in 2006. So I think, what's that, 14 years we're going on. I started as a SolidWorks support application engineer, and I trained customers on SolidWorks and also provided phone and email support with SolidWorks. So I come from a CAD background. It kind of helped transition me over to 3D printing because I was already familiar with customers designing components and had a good idea of some of the limitations with CAD software. And as we got into 3D printing, it was kind of a nice transition. And currently I help customers with pre-sale support and post-sale support. And I've got a presentation I'll get up on the screen here. So in terms of pre-sale support, I help coordinate the site preparation planning. That involves coordinating the shipment and delivery of your printer. So once you purchase a printer, I send out a site prep guide that will help describe the size and the weight of your printer, what to expect in terms of the crate. We'll discuss your electrical requirements. Some of our printers require special electric setups. We'll make sure your installation area is big enough for the crate that you're about to receive. And we'll also discuss material handling and storage, because that's very important for these printers to have their material stored properly. Once we're ready for the installation, we also plan for the training. So I may have you install the software ahead of time, or we can sometimes do it when we're at the customer site. During the training, we go over the touch screen interface on the printer. We go over all the functions inside of that. I'll demonstrate how to load the material into the printer and how to unload it, and in case you don't need the printer for a period of time. And we also discuss the operator maintenance tasks. As far as what to expect on the installation day, it's always an exciting day to show up. And some of our printers we uncrate it for you. Other ones we need to have them uncrated ahead of time because we need an electrician to actually hardwire the printer. But once we arrive, we power up the printer for you. We'll show you how to load the materials. We'll connect it to your network. We install workstation software if you haven't done that already. A lot of times people like to get a head start on that. So we'll oftentimes give you a download link to get the software set up on your computer ahead of time so you can start, practicing loading your models into the printer software and experiment with different colors and things like that. We'll also, as I mentioned, we demonstrate the basic operation of the printer and cover all of the maintenance tasks. And it's always exciting at the end of the day to send a test job to the printer. So before I walk out the door, I like to make sure you're comfortable setting up your job and your software, make sure it gets sent to the printer okay, and make sure that it starts up as expected. In the event you have questions after the install, we're always here to help. Alongside me, we have Bennett Meglino. He is one of our field service engineers. He comes from an electrical engineering background, so he has a very good understanding of all the electromechanical components inside your printer. And he's also very good at explaining all of the things that I cover during the install as well. So he's a great resource for us to have in-house. And you can contact us through either phone or email. Either one works well. We, during our troubleshooting process, if there's an issue, a lot of times we like to get descriptions of the error messages that you might have. If there's any photos you can share of the resulting print, that helps a lot. We sometimes request the models that you might have used for printing. So a lot of times that's going to be your STL file or your CAD file. We like to load that into some software we have. We'll check it for any unknown errors that might have been there. And a lot of times we'll collect log files from the printer. That kind of gives us a history of what happened during the print. And in the event we determine we need to visit your site in order to address the issue, we offer those services as well. We also offer preventative maintenance service. So, either yearly or on an hourly basis, depending on how many hours you put on the printer, we like to come in and replace components that are known to wear on your printer. Usually it's annual. There's a handful of items on each printer we like to replace just to make sure there's no unexpected issues while you're running the printer. And we also cover all of the basic calibrations during that time. We just like to make sure we catch any surprises before they happen. And if you have a service contract, the preventative maintenance is included in the service contract. At the end of the 1-year warranty, I'll be sending out an email just reminding you that the 1-year warranty is going to be expiring soon. And we currently offer 2 plans for service contracts. We have Emerald Care that covers all the non-consumable printer components. There's also travel and labor included with Emerald Care. And recently we offered an Emerald Care Plus. And what that includes is backup printing. So if we determine after troubleshooting that we can't resolve your issue over the phone and we need to schedule a service visit, at that point we can start printing your parts in-house on one of our printers until you're up and running. And in that case, we charge cost of material plus 20%. So it's a very, very discounted rate from our standard service bureau rates. And the other benefit with Emerald Care Plus is, let's say you need a material that you don't currently have on your printer. Let's say you have a Polyjet printer, but you need a material that can withstand autoclaving for just a particular job. If you have Emerald Care Plus, you can send your job to us and we'll give you a 20% discount. And that also works in cases where maybe you need large parts printed and maybe you need to have them run on our Fortis 900, or maybe you just need a lot of parts printed in a short amount of time. We can definitely help you out with that, but if you have Emerald Care Plus, you'll get that additional 20% discount. So if you have any questions with what I presented, feel free to enter it into the chat, and I'll do my best to get back to you. And with that, I'm going to hand it back over to Justin, and he'll wrap up, and we'll probably take questions from there.
Thanks, Chris. Real good. Appreciate that. So yeah, thanks everybody for joining. And it doesn't seem as though we have a lot on the call right now, but I wanted to open up questions to Q&A. If there's anybody out there that still has some questions regarding our capabilities, what we can offer, what machines that we're offering through Stratasys, all capabilities, I'd like to hand it over to Colin in Q&A. And thank everybody for coming. If there's an opportunity that you'd like to come in and see our facility, we are wide open to do so. Again, as Jordan mentioned, small tours, and give you guys an understanding of how the machines work from inside and out. So with that, I want to, come to an end and thank everybody again.